Hello everyone. I am Kanpur. I will be a tutor in the course Basic Electrical Circuits, which is offered by NPTEL. I will be tutor as a part of the prestigious Prime Minister Research Fellowship Program. As part of this program, we are supposed to teach for 1 hour every week uh, in a college, or as recently started, we are also allowed to teach in the NPTEL program. So we are here to help the students like uh, uh, mitigate with the problems that they face. Actually, so what happens is that in any NPTEL program or a MOOC program, what happens is there is very less scope for interaction with the professors. So the aim of this tutorship is that we can mitigate with that gap. We can basically reduce that gap, and so the students can benefit more from this NPTEL program. Okay, so let us go ahead and let me share my slides. So I hope this is visible. As I said, this is a course on basic electrical circuits. It is offered by NPTEL. I will be your tutor. My name is SWAYAM. I am a PhD student at IIT Kanpur, and also a PMRF scholar. Going ahead, so this is a week 0, or this is simply a dry run to check whether the software is functioning properly or not, or there are no unwanted glitches during the presentation. So let me just briefly go through the content of the course. What can you expect from the course? What we will be expected to do in the course. So basically, this course offers a basic introduction to concepts of electrical engineering. What are those basic concepts, you ask? If you ask those basic concepts, these are like network theorems, mesh analysis, nodal analysis, all those things, like circuit analysis using Laplace transforms. So I hope that students here have heard of Laplace transforms at least. So here you will be understanding what they are and how to apply them to the real circuits to solve difficult problems in the circuits. So many a times you will see that circuits which can be very complex to analyze in the time domain or in the regular time domain, they will become extremely easy in the Laplace domain. Once we find out their Laplace transforms, they will become extremely easy to analyze and move ahead. Also, you will be learning about analyzing analogous systems using the concepts that you learned in this course. Like I hope that many of you have prepared for JEE. At the time of JEE, you must have seen your institute coaching teachers giving you tricks, teaching you tricks to solve spring mass systems and all. So basically, spring mass systems, they are converted to an analogous electric circuit, and then it is solved easily. So those kind of concepts will be taught here in when you will be taught analogous systems. So the prerequisites for this course, as such, there are none, but still you are supposed to know some basic concepts, and they are like basic concepts from your high school physics, like electrostatics and electrodynamics. By electrostatics, I mean what is a charge, what is the unit of charge, and things like that. By electrodynamics, I mean what is a resistance, what is meant by current, what is Ohm's law, just the basics, not very detailed Ohm's law and all. You should know those things. You should be comfortable with those things. We will anyway cover those things in this course as we go along. And if you have gone through the week one content, you must have seen that those concepts are revisited in the week one content. Other than that, you should be comfortable with some basic engineering mathematics like linear algebra. Like you should be knowing how to manipulate matrices, and what are determinants, what are matrices, and you should also know how to play with complex numbers. Not very much, but still, the complex numbers like uh, you will like in the week 0 assignment also, you must have seen that you were asked some questions regarding the conversion of a complex number from its normal form to polar form and all. So those things you should know, those things you should be comfortable with. You will be given some problems related to that in this course also, and if you have doubt you can always ask me, but it will be good if you can refresh those concepts. Other than that, you should be comfortable with ODE, like ordinary differential equations. They will be used in this course, and you should know what they are. If you have not, if you have forgotten those concepts, you can refresh them once. That will be better. So moving ahead, I will be going through some like some questions in the week 0 assignments, just for revisiting some concepts. Okay, so the first question in the week 0 assignment was regarding the Ohm's law. So voltage across a resistor. So voltage across a resistor R carrying a current I is given by. So okay, so basically, if you have a resistor like this, if you have a voltage source here, so what is the current? I? So we know that Ohm's law says that voltage across a resistor which is carrying a current of I is equal to V is equal to IR. This is the Ohm's law. So this is actually what will be the answer here. So this is the correct answer here. V is equal to IR. Again, current through all the devices connected in series. So what is meant by series connection? So series connection, the definition of series connection is that two devices or two or more devices are called to be connected in series when the current through all of them is the same. Basically, suppose I have a device like this. Okay, there are two terminals. Then again I have a device like this. Then again I have a device like this. So all these devices, when connected through a voltage source, so basically when the current through all these devices are same, you see this is also I, this is also I, this is also I. At that time we say that all these three devices, device 1, device 2 and device 3, they will be in series connection. Yeah, so these devices will be in series connection. Basically, from the definition of series connection, the current through all the devices connected in series is same. This is a true statement because this is the definition of a series connection. Moving ahead, equivalent resistor of resistors connected in parallel. So you must have seen this question in your high school physics. You must have also studied it, that when many resistors are connected in parallel. So this is one resistor, this is another resistor, this is another resistor, this is another resistor, and so on. So basically, when all these devices, all these resistors are connected in parallel, the equivalent resistors of all these resistances, that is R equivalent, is a simple resistance which is given by what? R1 parallel R2 parallel R3 and so on. This all the equivalent resistance of all the resistors connected in parallel is basically less than the minimum, less than all the individual resistances. Basically, this is the answer. This is the correct answer. What is the equation? 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by r3 plus and so on 1 by rn. So if you solve this, if you solve the R equivalent and given all the values of this resistances, you will see that the R equivalent that comes out is less than the minimum, less than even the minimum value of resistance that is put in the parallel connection. So it will be definitely less than all the individual resistors. So option A is the correct one. So like this, solve the questions in the week 0 assignment, and if you have anything, you can ask. You can always come back to us and ask us. You can also post your questions in the discussion forum, and we will be happy to answer those questions. So okay, so all the best, happy learning. We'll see you in the I'll see you in the next discussion session. Thank you.